Hopefully you all can see me. I'm laughing. I'm laughing because I was just reading Marshall Baufnoffer's comment. We need to design a space weather woman suit for Tamitha. Could you see me? I'd be like Wonder Woman. It'd be so hilarious. Come on, help me. Oh, you guys keep me laughing, especially when it's not been a laughable time in my life recently. So thank you so much for that. Good to see all of you. I hope I'm on. Whoops, I need to update the feed here. I scrolled back to look to see who was on and what you guys were chatting about. and so my feed wasn't, there he goes. Now it's scrolling. Oh, that's cool. Great to see all of you. I see Lourdes. I see Jerry. Thank you for being on. I see John. I see Jay. Karen's on here. Dr. Bacon. Awesome. Hello. Lisa. Oh my goodness. All of you. That's so great. Thanks so much, guys, for coming on. Okay. Yeah. So if you will notice, I am not drinking out of my typical mason jar today. I'm actually drinking hot tea, which is not really a good mason jar thing to drink out of. So forgive me, but yeah, I have a kind of an upset stomach, and it's just, I am broiled in multiple lawsuits, sadly. And it's just getting horrible. My daughter has a house that was willed to me to give to her for my grandmother. And I've got multiple people trying to take it from me. And it's just, it's amazing how money makes people go nuts. I can't deal with it. So yes. So tea has been my recipe for trying to keep myself well and not losing my mind. But yes, it has slowed me down a little bit, as you can tell on the forecast front, and this is probably going to drag on for months. So if you see me doing more live briefings, it's probably because of that. It's a little bit easier for me to do live briefings than do the big heavy productions, which I guess maybe you guys will like better. So just expect to see more of me. Hello. Okay. So hopefully everybody knows that there is a solar storm coming. I will do my best to get through all of the forecasting for you and show you kind of why both NOAA and NASA, and sadly, I haven't seen the Mosswalk give us a prediction, but I'll tell you why they're so kind of off. They're almost a full day apart. And we'll go into why that is. And it will also give you some insight as to how we really do need to improve space weather forecasting. But I mean, everybody does the best they can. So you can kind of look at these different agencies' predictions as like a bracket. That's kind of nice in a sense, because it shows you kind of how much error we have. All right. And I will get to, yeah, money, death, and both. Right, Rich? No kidding. I know it's awful, and I'll answer some questions about all that after we get through the forecast. If anyone's interested, I'll maybe give you a little bit more info on what's going on in my life. But let's talk about the sun first, shall we? Okay, so we have, let me make this a little bit bigger. We have some fun stuff going on. Don't get too excited. Oh, am I backwards? I may be backwards. I hope not. It's backwards in my view. Shoot, hold on. Let me change the view so that I don't have to look at a mirror. I hate looking at a mirror. There, wait, did that work? No, let's try again. There we go. Okay. I don't like looking in mirrors. It doesn't make me feel comfortable. All right, yes, East Lim is East Lim. So we have 3 different regions that have been rotating into view and kind of emerging at the same time. We have region 2974, 75, and then 76. 75 and 76 are kind of smeared together. All the other regions over here have kind of been defunct. So even though there are a lot of bright regions on the sun right now, there's just only 3 true active regions. Now, we were all excited about these regions up here, 75 and 76, as they were rotating into view, thinking, ooh, M flare players, maybe. Turned out the M flare came from this guy, the teeny tiny little guy, region 2974. And you'll see you can see that they've all been kind of firing paparazzi bulbs, but that was the one right there. That was the M-class flare. Wasn't a huge M-class flare, but it did actually create a very nice eruptive wave. And I'll show it to you guys here in a minute. And it launched a solar storm. I got to be careful when I say that solar storms are not launched by solar flares. They're 2 different phenomena, but they oftentimes happen simultaneously. And that's why you got a solar flare and a coronal mass ejection, a big solar storm at the same time. This thing did end up being, it looks like it would be going westward or eastward of Earth. That was it right there. But it actually, as we'll show you by the what we call the EIT wave, which is the blast wave, it actually looks like it's going to be coming toward Earth, and so it is partly Earth directed. But that's not the only thing we have. We have a coronal hole, and I'll show you a bit more about that in a minute. That coronal hole that you can't see in this wavelength, but I'll show you the pink sun. You can see it really well. That coronal hole is actually sending us some fast solar wind, and that might muck with this. And it depends upon your point of view and depends upon the model that you use as to whether or not it interacts and pushes this off to the side, or if it slows it down or speeds it up. I'll go into that when we talk about the models. But that is part of the reason why we have such a discrepancy between both NOAA and NASA this time, is it really has everything to do with the coronal hole that you can't see here, but you will see it in a minute. Meanwhile, we do have a couple other regions, and I'll show them shortly, that are going to be rotating into Earth view that will keep up that solar flux. I don't know if they're going to be M flare players. In fact, I think the M flare risk, since we're on this looking at flares at the moment, I think the M flare risk really is going down. I think last I checked, it was about 5%. Yeah, and I agree with that assessment. Really, when we look at the actual sunspot clusters, they've really kind of quieted down a bit. And I don't think we're going to get any more big radio blackouts unless something new happens, unless something new grows. And the regions rotating into view, it's going to take a few more days before we discern whether or not they're going to be flare active. So that was the flare story. Let me go ahead and show you the pink sun, just so you can get an idea. Whoops, let me turn that one off. Hold on. I should stop this because otherwise my system starts going, I'm working too hard. All right, so let me start this. Now, here is where you get to see, make sure I keep the date. Come on, there you go. Here's where you get to see that coronal hole. See that? So this is kind of fuzzy wuzzy, had a little bit. All right, so here's the coronal hole that's been hitting us recently. Okay, this is kind of, it's just a remnant kind of disturbed stuff. Here's the second coronal hole. It's actually reasonably well formed. If I were to show you in 193, which is the bronze sun, you would see it's smaller. It is smaller than this, and it's okay as far as a coronal hole is concerned. It's not the deepest or the fastest solar wind, and that's where I think, sadly, I think NOAA actually is expecting too much of this coronal hole. It doesn't look to be as well formed as they would like you to think, but it is nonetheless going to bring us another burst of fast solar wind. Looking at stereo data, it really isn't bringing us that fast, but again, I'll talk about that when I get to the models. But that coronal hole, that's where the fast solar wind is coming. Like I said, we saw the first burst from here. We'll see the second burst here over in the next day or so. Aurora photographers, don't get super excited. Not only is the fast wind probably not going to be all that fast, but it's also the wrong polarity. This coronal hole we are at the spring equinox. And yes, that typically means, for those who are savvy, that means the Russell-McFerrin effect is in full swing. Right, but it also means that not every fast solar wind that you get or any solar storm that you get, it doesn't automatically mean it's stronger. It means a certain polarity is stronger. And this has the wrong polarity. So if anything, it's going to be less active and less impactful than it would have otherwise. So just be aware of that. Don't expect a lot of aurora from that fast wind. What it will do, though, is it will disturb the Earth's magnetic shield enough, even though we won't get a lot of aurora at mid-latitudes from it. But it'll disturb the shield enough to make it more susceptible potentially to the solar storm that we're going to get. That's going to be hitting us soon. Now, I'll wait for this thing to go, and when it fires early on the 25th, you can see here, early on the 25th, when it fires, whoops, did it just fire? Oh no, here we go. Watch this blast wave. Whoosh, do you see that? The blast wave comes clear out to here. And I'll show a more detailed movie here in a second, an animation that expounds on that. That blast wave lets you know, A, that the thing had a lot of force as it launched, so a lot of acceleration. This thing was going to come out fast, but also it gives you an idea of the extent of whether or not this structure actually could hit Earth. Because if you go past the central meridian, anytime you get a blast wave that'll pass through central meridian, it gives you a very good chance. See how it went past it? Central meridian is here. That blast wave went past it, which gives us a good indication that this, at least part of this, is Earth directed. And so that was pretty exciting. And if I pause this for a sec, let me pause it, and I'll pull up an animation. This is from Solar Demon. I like this animation. This is nice because it does a base difference image execution of, hopefully this will loop. It probably won't loop. What I've done is I was kind of scrolling back and forth so you can see kind of the bounce back and forth. You can see it. You can see me rocking it back and forth. There's the actual eruption in base difference. It really shows the features, and you can see how big that blast wave is. But you can see how far it went past, right? It went past central meridian. So that's what I'm talking about. And that gives us a really good indication that we actually did, or we actually will have something that is Earth directed. Boy, that is a loud helicopter. Sorry if you heard that. So what do I want to show next? I will go back to this, and I will show. I'll show the HMI stuff in a minute if it's important enough. Poop. What was I going to show? Where's seeds? Is this it? Okay, yeah. So this is the chronograph for this particular event. Now, this is the LASCO chronograph aboard the SOHO spacecraft, which is looking at the sun from Earth. Okay, so what we're looking for is something called a halo. This means that we have a blast that comes out from the sun, and it gets bigger and bigger and bigger, and it surrounds what is the sun, because as it gets closer and closer to you, it surrounds all the way around. So if the sun is located inside this circle, then what we're looking for is something outside the circle. When we make our false eclipse, something that goes outside this circle all the way around. And it's hard to tell in the straight images because this is a wispy structure, but you can kind of see that ghost image kind of thing coming out. So you see that, but it's much easier to see in the difference images. And the difference images show what's behind me, but it takes one image and then subtracts it from another, from another, from another, in order to enhance the features, right? So, and I won't talk about the colors, just know that you can see the black and white stuff coming out. And yeah, you can see it looks pretty much like a full halo, right? You can see it actually coming all the way around here. Granted, it's far more, directed toward the east. So it's going a little bit more towards stereo. But when we actually look at the stereo chronograph, stereo A, it's actually showing the structure going off to the west of stereo. So the dead ringer spot is actually in between stereo and Earth. And that actually gives me a little bit more confidence that, yeah, we are going to be seeing this at Earth, no problem. In fact, you can actually still see that halo, the blast wave, coming out even on this side. The issue that we might have in terms, and I think you'll see this when I show you the models, which I'll show next, or I'll show in a moment. The issue that we have is that just because we see it coming out at the sun, and it's a full halo, the issue that we have is that we have there's a lot of traffic that these storms see on their way to Earth. And so if something is in the way, I don't know, like maybe a fast wind stream, it could deflect the structure, right? And in this case, if it's going to be deflected, it's going to be deflected more to the west. So making sure no one is telling me something's bad. Okay. So that's the issue, is that yes, the structure as it comes out of the sun definitely looks like it's going to be hitting Earth, and actually almost a direct hit, because this is pretty well a full halo. But with that stream, it could be deflected so that we only get a flank impact. And that's why when I show you the models, they show that. For those of you who actually can read chronographs really well, go, why, with a nice pretty halo, why are we showing such a side view or side impact? Okay, let me just, for completeness, oops, not this, not you. Where are the one? Oh, okay, there it is. Just for completeness, I want to show the X-ray flux. So you can see we're actually sitting in the X-ray flux. We're actually sitting right at the seafloor. Okay, we've been going down just a little bit since that big flare. The background X-ray flux has dropped a little bit. It has been building again. So I need to figure out which region is causing that build. I'm not exactly sure which. Maybe one of the new regions rotating into view. But I don't think it's region 2974. I think that region is calming down. But it did launch this. This was an M-class flare, 1.4. And since then, pretty much nothing. We're not going to be dealing with, hopefully we're not going to be dealing with any more M-class flares for a little bit, at least over the next few days. But that solar flux is still staying nicely centered at about 110. It may drop down just a little bit, but I doubt it at this point because we have some new regions that'll be rotating into view. So amateur radio operators, hey, enjoy, because sitting in the triple digits really helps with storms like what we're about to see here. Dayside propagation may not be that big a impact. Night side, of course, could be, but dayside probably not too bad. Okay, so what do I want to show now? Let me show you. Yeah, let me show you let me show you the models. Okay, so let me talk about NASA model first. So here's the NASA prediction model, and I'll end up putting both of them up at the same time. Put that over here. I'll end up putting NASA and NOAA up so side by side so you can see it. In this case, I've taken the NASA model. I know you're used to only seeing this bit of the NASA model. Oops, let me make sure it loops as well, because I think it wants to not loop. All right. So here's the NASA prediction model. You're used to just seeing the top panel, but I went ahead and did the bottom panel this time. Top panel's density, bottom panel's velocity or speed, which is probably a better indicator. Density, if you wanted a layman's term kind of translation, strength, speed. Makes sense? So that we have to pay attention to both of them. How strong is it coming out, and how, in other words, how dense, how non-wispy is it, and also how fast is it moving. So these two factors are obviously not the only things that we would use to gauge, but these are two things that we can gauge faster than real time when it comes to these storms. That's why they seem so simplistic. It's like, why are these models so simplistic? Well, it's because that's the best we can do faster than real time and actually have a forecast prediction. Okay, so you see, so you're looking down at the sun from the North Pole. Earth is off to the right. I've got it nice and labeled. So this is in the ecliptic plane. This one is a cut that goes north-south. So again, here's the sun, but the North Pole is up here, right? And Earth is this way. And you can see this structure, this solar storm that is coming out, at least with the density, the solar storm is coming out in such a fashion that it's mainly going east of Earth, okay? Stereo, however, if you look at stereo's coronagraph, it doesn't look like it would be this. It actually looks like it's a bit closer, more toward Earth and going a little bit, so this, sadly, this looks like it's kind of moving, and it's likely because of the ambient solar wind. It looks like it's actually the structure is actually being deflected a little bit off to the east of Earth, so that when it hits Earth, it will end up being the west portion of this structure that will hit Earth. However, that being said, the fastest part of this structure is also right here, and I'll tell you why. If we go down here, this is why I needed the speed component. If you're looking down at the North Pole with Earth off to the right, what you're seeing here, do you see this pinwheel? Like this pinwheel arm, right? Similar to these pinwheels, okay? But this pinwheel is actually showing the high-speed stream itself. These pinwheels are actually showing the density wave in front of it, the density compression in front of it, okay? So here's where the high-speed stream is. Now, NASA considers the high-speed stream about 550 kilometers a second. Part of that is due to the inputs. Part of that is due to the version of the model, which I've got down here. Hopefully you can see it. It almost gets cut off. NASA does use a different version of NLL than does NOAA, okay? So just be aware. So they have the high-speed stream being around 550 kilometers a second. I would say from recurrence and looking at the way, looking at the coherency of that coronal hole on the Earth's facing disk, I think this is a good estimate, okay? You'll see in a minute that NOAA assumes it much, much higher. But by assuming this is 500 kilometers a second, and then also assuming that the fast solar wind here is actually kind of calming down and not picking back up again, what that means is that this structure is not being guided nearly as dramatically through this fast solar wind. You are seeing it as being accelerated a little bit, see? because you get a little bit of green. It starts out kind of, well, it starts out really fast, but it's slowing down in this case, but it's still moving reasonably quickly. So the fastest part of this structure is actually hitting Earth, and it still will be around 550 kilometers a second. I do believe that that is a pretty good estimate. And is that part of why this structure has been deflected this way? Possibly. Oftentimes that is what ends up happening, is that you get fast. If the solar wind here is faster than it is here, the structure will either be deflected out of it and move away from it, or it'll be stretched and torn. Okay, and you're seeing a little bit of that stretching. In fact, when you look at NOAA's version, it stretches even more and tears even more. At any rate, all of this being said and done, the impact is about, according to NASA, is literally at midnight on the 28th of March. Okay, and it comes after, essentially after a lot of this fast solar wind, or at least at the tail end of some of this fast solar wind. Okay. Hopefully that is clear. I won't go over what the impact footprint is, but it just basically makes a splash in and around Earth. It lets you see where Earth is. Sorry, my arrow moved. I need to be careful with my arrow. Earth is actually this yellow dot. And yeah, so you can start seeing the impact both in the splash screen for density and the splash screen for speed as well. Okay, so that is, I'll stop you. Now let's take a look at NOAA, and then we'll put them both up together. So in NOAA's case, once again, same kind of idea. Oh, I'll probably have to loop it again. Yes. Okay. Start it over. Okay, so in this case, again, we're looking top panel's density, bottom panel's velocity. Again, you're looking at a storm that's coming out. You can see it looks a bit more shredded this time, right? It's being a bit more shredded, and that's because we've got in the velocity panel, the speed panel, look at this really high velocity speed. As a matter of fact, let me stand on this side so you can see. NOAA puts their quantitative measurements here, their color bars here. When you look at the structure in NOAA's model, you're looking at one that actually shows the first fast wind speed from that very first coronal hole that we've already passed. That one, they're showing it about 700 kilometers a second. That's a little high. I don't think we saw 700 kilometers a second. The second burst, they're also showing at least 700 kilometers a second. Once again, I think it's too high. Even though this model is typically a better model for solar wind, I still think that it's erring on the side of being too fast. We haven't seen a lot of high-speed streams recently, especially from this coronal hole, either at stereo or even the recurrence from last time that this coronal hole was that gave us solar wind speeds that were that high. So there's been two indications that this is too much, which is, it is what it is. Do I think their structure is better? Yeah, because they've got two streams as opposed to one. So I don't want to fault NOAA and say NASA's right, NOAA's wrong. No. They're just different. These guys have better structure, but I think they've overestimated the speed. So when this structure launches, if I go back up here, I'm sorry, I'm looking at trying to make sure I'm pointing in the right place. As this thing starts over and you see this structure coming out here, come on. Come out, please. There you go. As this structure comes out here and you see it being shredded, you do still see that this structure is actually got the fastest part of it, right, hitting Earth. So same kind of thing as before. But because it's showing it not only launching faster at a higher speed, see it's all red here, and it doesn't slow down at all, right? NASA was showing it at about 550 kilometers a second, which would be about the yellow in this thing. This is staying all red. So not only does NOAA have a faster solar storm moving out, but it has a faster solar wind stream than NASA. And that obviously helps make the impact time occur a lot sooner, right? So we're talking about 600 UTC on the 27th, which is soon. Do I think that that's a little too soon? Yeah, I do. Do I think that the solar wind stream is going to be, pushing 700, and the CME itself, the solar storm itself, pushing 800 kilometers a second? I don't think so. I think it's too fast. I've been wrong. I've been wrong many times. So, I'm just another scientist in the loop, guys. That's it. I can sit here and critique this all day long, but in the end, we won't know till it gets here. So I think it's a good bracket, right? That NASA or the NOAA version is going to be on the fast side. NASA version may be on the slow side, at least a little bit on the slow side. So it's a good bracket. But what you can always bank on is that, at least for the initial impact, if the solar storm hits early, right, hits sometime on the 27th, at least the initial impact could give us some decent aurora. It'll be a bigger punch, right? It'll be a stronger storm. If it, the longer we wait past this impact time here, then the slower the storm is and the less impact it will have. Okay. As for magnetic field configuration, who knows? That's always something that we have to wait for in real time. It's really hard to tell. And it really is, in situations like this, when you have so much traffic, so to speak, coming from that you're dealing with on the way from sun to earth, I wouldn't trust any solar-based magnetic field configuration. So what we see on the sun, I would not presume to think that that's what it's going to be when we hit Earth, simply because of the amount of traffic that it has on the way to Earth. Okay, so if anyone is saying, I know what it is, the slinky is going to be oriented like this, and I don't know, I think there's a lot of argument for why that's not probably the case. Now, what I'll do here, just for fun, is that I will put these two side by side. So let's see, did it stop? Oh, no, it didn't stop. I'll make it stop in a sec. So I'll put this here so you can see there, and this one, where's the, oh, poop. Maybe that made it stop. We'll see if it made it stop. Are you going to stay stopped? Maybe. Okay, if it does, so let me get out of the way. So you can see now, again, if we look at the spiral arm, right, this Parker spiral, kind of the density from the velocity from the solar wind stream, you can see it high, but it's only about 550 kilometers a second. Here they're showing that first spiral being much higher, around 700 kilometers a second. Here they're not really showing a strong peak for the second arm. Okay, and maybe that's a good estimation too, that maybe that solar wind is really only going to be around 450 or so, not even 500 kilometers a second. Can I close that? Let me close that down. Okay, so maybe not even 500 kilometers a second for that second solar wind peak. Here though, NOAA is saying, yeah, it's still going to be quite strong. So that coronal hole that we're watching rotating, it's almost ready to rotate right through the Earth strike zone now, that's this stream. And I do believe that they're overestimating it. But that is why you're seeing a much slower impact time for this structure than here. Okay, hopefully that makes that clear. And that is why also we have such a big discrepancy. Anytime we have fast solar wind, or some other solar storm in front of it, some other traffic, that the solar storm is going to encounter on its way to Earth, all bets are off. And models have a tendency to get really different, really fast. Okay, so hopefully that clarifies that. And let me go back to, so what else can I show you? Let's go now to stereo. So what else does the sun have in store for us this week? You guys are used to me saying that, right? So what else does the sun have in store for us this week? Well, this is stereo A. One of these days I'm going to wake up in my sleep saying, why am I saying this? Like I'm saying it in my dreams now. I'm so used to it. Okay, so here's that coronal hole that is beginning to rotate in through the Earth strike zone now from stereo's view. Remember, stereo is looking at the sun just a little bit from the side, and so it sees a little bit back further behind the into the far side of the sun than we can see. So what it's seeing, this is region 27 or 2974, 2975, and 2976. In just in a very short bit, you will see this thing kind of fire. When it actually skips a few frames, sadly. There's probably yeah, right there. You didn't see it very well. It's probably some automated, wait, I think these frames are bad, from the algorithms, and then they'll release them. But we did get, I think there is a radiation storm going on from that thing that Stereo is seeing. Not a really big, strong one. And I'm kind of surprised we're not seeing it at Earth. But if you look at Stereo, if you're interested and you look at Stereo's data, you actually do see a small radiation storm going on there. Pretty low level, but nonetheless, it's registering. But I think that for the most part, all that's over. Now what we're going to be paying attention to are these regions over here. They don't seem like they're all that active, but they're bright. So that's, some of that is limb brightening, granted, but we are seeing a little bit of activity here and there. But this is great for amateur radio operators, because you're going to be getting a lot of good boosted flux here soon. And so we may actually edge up even higher into the triple digits. It's definitely a good sign. And we're very, very happy about that. See all this right here? There we go. Now you're really seeing it. So don't know, we're watching some of this with a lot of synergy. If I were to stop that thing, maybe I'll move the movie back one more time. You're seeing a lot of synergy between this region here and 75 and 76. Seeing a lot of synergy between this. I'm not exactly sure what's going to go on. If these regions start developing, then I will say, yes, we're going to have more M flare, and we could actually see it even growing from this, but not quite sure what's going on there yet. But nonetheless, I don't think we're going to slow down when it comes to getting that solar flux boosted. So stay tuned, but I will stop short of saying that these new regions that are rotating into view in probably about 3-4 days, I will stop short of saying that they're solar storm producers. I'm not really sure. Right now, they look a bit quiescent. So they may be big, but they may be getting close to being plages. So we'll just have to see. Okay, let's see now. What do I want to show you now? I probably could show you the moon. You guys, anybody interested in the moon? I actually realized I forgot to look at the moon. Anybody use Moon Giant? Yeah, so it's nice. Okay, so look at that, guys. So we're going to be essentially at a new moon at the end of the month, which is very nice. But easily by the 28th, right? We're noon on the 28th. We're going to be, dropping down. So even if it's dim aurora, it's going to be a lot better than what we've had in the past. The last solar storm where everybody was fighting this full moon. It was like, oh my goodness. And even though it was a nice strong solar storm, the moon was just driving us crazy. So this time, if we have some chance of aurora at mid latitudes, if the solar storm hits and it's strong enough and it's the right orientation, then yeah, even if it's not the strongest we've ever seen, which this one isn't, you have a fighting chance, because the moon is really it's really becoming dim, and that's a good sign. At least it's not a full moon right now. All right, so let me go to 5-day outlooks. So this is just for I've started today. I didn't make a new one for tomorrow, simply because it really hasn't changed much. At high latitudes, NOAA is expecting major storm possibilities of about a 65% chance of a major storm. That will probably stay. But again, as we saw from the NOAA model, right, these official 3 days are made from the NOAA model, not the NASA model. If they had a NASA level prediction, this might drop down. I would say probably a 50% chance, but probably minor storming. And then again, it drops pretty quickly after the initial impact, which they think is going to happen on early on this 27th, simply because it's not a huge solar storm. It's a bit wispy, and the fast solar wind that we're embedded in is not conducive to big geomagnetic storms. Right, the fast solar wind that we're in is it's actually the opposite. So it'll quell a storm pretty quickly. So that's why you see it kind of going down reasonably fast. At mid latitudes, we could get active conditions. but about a 25% chance of a minor storm. I think that's probably a pretty good estimate, even if it's the NASA one that impacts us. The reason why is because oftentimes just the slamming in of the solar storm and all the disruption that we've already had, kind of like I don't know if you've noticed, but we've been going through kind of some strong unsettled conditions already, just because we have, there is fast solar wind. And so we know that this one has been driving a shock. I don't know if it'll continue to drive a shock wave by the time it hits Earth, but if it does, it could easily bump us to active conditions, even if aurora is sporadic and fleeting. And then things, of course, will settle down as we move into early next week. So don't get super excited about this, all this fast wind and big solar storm. It's not that big. When we switch to our solar flare and particle radiation storm outlook, we are sitting in the triple digits thanks to these three regions. But region 2974 has really dropped its flare class. I mean, we do have about a 5% chance of an M-class flare. I wouldn't worry about it too much. As a matter of fact, I'm not even thinking that it's going to last through the rest of the week. We could easily just drop back down to 1% and everything will be nice and quiescent. But I'm not expecting the solar flux to go away. As a matter of fact, as I continue looking at stereo, I might actually raise this back up a bit because the solar flux definitely looks like, as these new regions rotate into view, probably around Tuesday or Wednesday is when we'll really start seeing them. That could boost the solar flux up. They're looking a little bit brighter than I thought they'd be. And then particle radiation storms, at this point, I think I should be dropping us down to a D1 normal level, because right now, I mean, we really are beginning to drop down in flux. I'm noticing that the magnetic equator on the sun, according to the models, is really beginning to tilt, which is nice. That's telling us that the dipole field that we usually have, that's nice and quiet. So like if I'm a dipole field and I have a north and a south, and my equator, what we call the ballerina skirt, the heliospheric current sheet, is normally very straight and quiescent. As we move to solar maximum, it tilts like this, or it tilts like this, depending upon your point of view. And so we're beginning to really see that tilting, and it's kind of nice to see that in the models, even if the models are slightly off. I love seeing that. As a matter of fact, I probably have that. I could show it to you. Yeah, I do. Oh, wait, that's the wrong one. Don't I have another? Yes, I do. I have another Lockheed Martin one. Yeah. So I love Lockheed Martin. They're so wonderful. They got a lot of their forecast stuff up for people to look at. Whoa, slow down. So they do. Lockheed Martin does a nice prediction using AIA data. This is 211 angstroms, the pink sun, and you can see this one here. That's the coronal hole. Whoop, here. I really should slow it down more. I'm probably getting everybody dizzy. That coronal hole is the one that's going to be affecting us. It does have positive polarity, which means, sadly, for spring equinox, it's not going to be geoeffective. It's the negative polarity, it's the one down here on the other side. That one will be more geoeffective. So don't expect big storms from this nearly so much as maybe that one that's coming around probably in the next 10, 12 days. That will give us more. But look at this. This here is the neutral line. Okay, now you can't always believe models. Models change. Things get weird. So you can't always believe it. But this is the first time I've ever seen a model excursion where the neutral line is jumping that high, to that high latitude. And that's telling me that solutions of the dipole field tilting, as we see, as we get closer and closer to solar maximum, that's a really neat sign. That's an indication that we're getting much more activity. Granted, it looks like it's a bit of an error. I mean, because you see it drops below these active regions. It can't quite make up its mind. A lot of this is automated algorithms, and things resolve themselves as time goes on. But just to even have a solution like that is quite promising, because it shows, it definitely shows that there's more activity and that there are viable solutions for a dipole field of the sun that's tilting that much. Don't worry, the dipole field is supposed to tilt. When it tilts, it means it's beginning to shrink, and as it continues to shrink, it'll tilt all the way until it disappears. And then we'll have a multipolar sun and we'll be at solar maximum. So happens every 11 years. Why people at Earth freak out about the Earth's magnetic field doing the same thing, I don't know why that's so crazy. It's fine for the sun to do it every 11 years, but Earth, oh no, it's Armageddon. Okay, really? Anyway, okay, let me go back to fun sun. Actually, I'll leave it here. This is a fun sun. I'll just let it do its thing. So I think that's it for all the information I have for you guys. So if you have questions, I will take questions, and I will also check the Patreon chat. I just wanted to make sure I got through all of that data first before we before I took questions. It's already been 45 minutes, so so let's see. Will it really hit? Will it really hit? There's so many rumors. How sure are you? Oh, how sure am I that it'll really hit? Yeah, it'll hit. Yeah, but it's not going to be, this is not going to be a huge storm. So even if it hits, unless you are chasing aurora, unless you are someone who works with precision GPS, unless you're an amateur radio operator or a drone flyer, you may not even notice, right? Solar storms are like rainstorms. I mean, they're mild inconveniences, and they're only mild inconveniences for those people who actually are dealing with, you know, susceptible technologies. So don't even worry. I can't tell you how many people think that every single time a solar storm hits Earth, it's Armageddon. It really isn't. I mean, it'd be like, the analogy is simply, imagine thinking it's Armageddon. You know, think of a weather person telling you it's Armageddon every single time a rainstorm hits. I mean, you'd lose your mind, right? Well, that's what all the YouTubers who do this kind of stuff, that's what they're doing. They're basically taking the space weather equivalent of a rainstorm and saying it's going to cause mass hysteria. I don't know. It's just rain. What's the big deal? You know, there's so much worse stuff going on in the world right now. A solar storm is not, you know, it's not the Armageddon. Ukraine right now is Armageddon, not this. So, okay. So hopefully that answered that question. So don't worry about it. Let's see. Armageddon. No, don't repeat it. You're so funny. Cool. I'll look for aurora at 9 p.m. tomorrow night. Yeah. Yeah, Lisa. Well, you're always out anyway, so I'm not going to worry about you. You'd be out there looking, even if the field were northward. You're like, I don't know. I don't care. I'm going to get out there anyway. I love it. Oh my gosh, stuff is scrolling so quickly I can hardly see it. I think people freak out about the Earth's magnetic field because we really don't know how or why it changes. Well, we know how it changes. Sure, we do. Look at the sun. It changes the same way the sun's field changes. As a matter of fact, UCLA actually has many Earth, dynamo models, and we don't know all of the interior aspects of it. We understand that it's an iron slurry, and we understand that there's aspects of really melting and freezing iron that changes how the convection patterns work in the molten core, and it's a really neat kind of process. And it's also a process that won't last forever, right? Because Venus is what Earth was many years ago, and Mars is what Earth will be in the future. Neither Venus nor Mars have their own intrinsic dynamo. They died, or Venus hasn't started theirs yet, because they're not cold enough yet in the interior of the planet. And Mars, its dynamo has already been here and is gone. So, it's very interesting where we are in our Earth system right now. And the dynamo is something that we do understand to some degree. And we do understand that it flips. So I don't think scientists are worried about it and are scared, but I do think that it has not translated to the public. So in that case, you are correct. We don't understand it from a public perspective. And it causes this hysteria that people just shouldn't have. Chicken Little. Yeah, I hear you. Space Karens. Oh, don't insult Karen. Don't insult Karen. Anyone who's named Karen. I feel so badly for people. I know multiple people named Karen, and I hate. It just kills me that name has been hijacked for a very specific purpose. But it's funny. I have to admit. Okay. Awesome. Radio reception is going to be great. I think so. I think radio reception is going to stay pretty decent on Earth's day side. Night side, of course, will be a little bit dicey. but I don't think it's going to last all that long. This is a reasonably wispy solar storm. When we looked at it through coronagraphs, even in the difference images, it really wasn't dense. And then when we looked at it in stereo, again, very wispy. So now that doesn't that doesn't mean that it's not going to have an impact, because we can't tell the strength of the magnetic field inside that structure by looking at the coronagraphs. We can only tell if it's going to be a strong bumper car or not. Basically the dynamic pressure it will have, or has the potential to have. So magnetic field, sadly, and particle density they're two totally different things. You can have a very strong magnetic field inside a structure that has very little plasma in it. That's not dense at all. So, I wish we could do better, but right now that's the best we can do. We can only make guesses on that. Okay. How can we distinguish a G3 level we know before? Okay. How we end up distinguishing it is really, sadly, only due to our upstream monitors. Because we do have multiple monitors sitting at the L1 point, we have about anywhere between sadly 15 or 20 minutes to almost upwards of an hour in advance notice. So we can tell whether something is going to impact Earth hard. We can, because at that point we're sitting in the structure as it's blowing over us, and we get everything we need. But we just don't have that much advance warning. So if you are active on Twitter, that's where we do the real-time forecasting. And so, it's one of the nice things is that you get a big forecast like this. And then if you want all the crazy details, then you can get on Twitter and follow the community there. And we have half a dozen, at least, scientists and growing who are doing active predictions, looking at as many spacecraft as they can and trying to give the community as much information as they can, so that people can see aurora, or they can prepare when it comes to like contests for amateur radio, things like that. Because obviously when these things hit, whatever side is the night side of Earth at that time really is the side that's going to be impacted the most. The day side gets impacted, but it doesn't get impacted nearly as strongly. And it takes a while for those impacts to kind of propagate to Earth's day side. If you want a rule of thumb for geomagnetic storms, when these big solar storms, when they hit Earth for amateur radio, switch to lower frequencies. That's really the best thing I can say, is that just try to switch to lower frequencies. They end up working. All right, longer wavelength stuff. Yeah, it's not the best solution, but it's one that generally works when these big solar storms occur. You are my density. That's so cute. Thank you so much. The stock market thrives on fear and greed. True. Yes, and so lawyers do too, sadly. Oh, thank you, Kat. I'm so glad. You just new here. You just found this channel last week. Oh, fantastic. Hopefully you enjoy it. I do both informal briefings like this and then the formal ones. But yeah, I do really try to interact with everybody. So ignorant person me, predicting tomorrow because of the migraine and arthritis flare today. Zero scientific knowledge, but I'm a human barometer. You are not alone. There are many people in both in my Patreon community and just out in society that have geomagnetic and other types of space weather sensitivities. I am working on a database, a medical database, with one of my patrons, one of my VIPs, to try to make some of this data and this medical studies that are reputable and published in reputable journals, peer-reviewed journals. I'm trying to make them available for you in such a fashion that is organized according to space weather phenomena. Because a lot of times it's really hard to wade through all of that stuff, because everything is lumped together. And unless you know the space weather phenomena that you're dealing with, because they cause different types of medical impacts, at least that's what all the anecdotal reports say, then it's kind of hard to suss all that out on your own. So I'm just trying to make it easier, not that I'm trying to diagnose or treat anyone, but rather just make that information available to you in a little bit more accessible form, so that you can sit there and maybe kind of surf through it and decide for yourself or decide with your doctor what kind of things that what impacts you, what type of diagnosis you want to make for yourself, and if it helps arm you with information, then I'm all for it. So that's what I'm trying to do to help. But that's coming soon. Yeah, that's coming soon. Oh, I'm glad you find that exciting. Yeah, we're trying to do it. There's just so many people that come out of that have approached me over the course of years that with so many similar issues that I would be remiss if I didn't try to help. So that's all I can do. Okay, John, getting dark in the UK now with clear skies. Yeah, well, you got a little bit more time. Let's hope that it'll stay clear for tomorrow, because that's when we'll get a chance. When will we see another Carrington event? Oh my goodness, I hope never. That is impossible to say. But if this cycle ends up being a slow or small cycle like cycle 24 was, we'll see them. We'll see them in this cycle. Whether they hit Earth or not, it's hard to say. We had almost three Carrington class events last cycle, and we missed one. That was the 2012 one that was very famous, and then we got clipped by another that was in 2017, not quite so famous, and then there was one on the sun's far side. Two of them were done by the same active region, which was the famous active region. I can't remember, but it would happen during the when Irma and Marie were when Irma was decimating Puerto Rico. That's when we had that one active region in October, I believe. No, yeah, October of 2017. October or September? September of 2017. I have a forecast. My most popular video, my most popular forecast is of that time period when I was forecasting that perfect storm. So you can take a look at it there. But yeah, if this cycle is the same as last cycle, we could be in for Carrington class events. It doesn't mean the end of the world. It just means we need to mitigate through strong storms. And we have. Earth has been hit by these types of events before. We have survived. We will survive again. Again, it's not a Carrington class. A Carrington class event is not Armageddon. It just isn't. We're smarter than that now. Okay. The physical symptoms brought me to your channel. Oh, interesting. Oh, that's interesting to hear, Sin City Girl. That's cool. Cincy Girl, I can't read. I'm glad to hear that, and hopefully, that kind of stuff gets me to really want to do that medical database for you all about a lot more. Make a shielding box out of HDPE. Yeah, I can't. I have no idea. Secret Owl. That sounds like a tinfoil hat. I don't know how. Again, I can't talk about the merits of any of that. All I can do is just help you suss out things like looking at the medical papers and organizing them according to space weather event. That's as far as I can really go. It's like the same kind of thing when people ask me about climate change. Climate science is hard, and space weather science when it comes to medical applications is hard. We can't deny that we're electromagnetic and electrochemical beings, so there are some impacts, but to what degree they are, that's really difficult to say. I think everybody's biology is slightly different. So, yeah, I think you will. You could probably see aurora. Stick with this community. Aurora happens a lot more often than you believe, and it comes down a lot lower in latitude. All right, I am going to. Oh, you're welcome. Thank you for the supporting thoughts for my family. I appreciate that. That's nice, DDW. I appreciate that. Okay. Yes, and I try to be. Ruby, I try to be positive when it comes to everything. No fear mongering here. You will never find me fear mongering. Even if there were a Carrington class event coming, the first thing I would say is don't panic. Okay. And I would tell you, and what I would do is I would dig in with all my contacts to find out what people are doing. And then I would tell you how some of these things are being mitigated and who's planning what and all that kind of stuff. I would do everything I could to let you know that we're not in a vacuum. Space may be a vacuum, but we're not in one. Everybody works on these things. We've all, especially when it comes to the extreme events. There's so many different people and experts, subject matter experts that work on these extreme events. And we're always trying to mitigate through things because that's the key. The thing that I find interesting is that nobody's ever solicited the public's help. And that's kind of silly because if it's power grids that people really worry about, and you have things like rolling blackouts, well, what citizen of the world isn't used to rolling blackouts for one reason or another? Well, you know, the power companies tell people to dial back their energy usage. Why can't we do that for a solar storm? I don't see any reason why not, because we tax the grids less, then they don't have as much problem. They can ride the storms out easier. So goodness me, why don't they have us help them, right? It just makes sense. So that's part of the reason why I think we could be a very powerful force for positive change in when it comes to a Carrington class event. We can actually help these utility companies ride it out. If they just, you know, if we just know when it's happening and we know what to do, then it makes a huge difference. And they may or may not want to acknowledge that, but it's true. Anybody who's been through a rolling blackout knows that, right? Okay, yeah, panicking never helps, especially in an emergency, right? So let me check on Patreon. I want to make sure if anybody has questions on Patreon, I get to it. I did have one question I know about, let's see, Tamitha, do you think we will see solar flux in the 120s in the next few weeks? And this is from Bart Pullerman. Yeah, I think it's very possible. These regions, if I go back, Bart, if I go back to, let me stop this. Let me go back to stereo. Where are you? There you are. And I let's start it and hold on. Well, I guess I can get out of the way so you guys can see. So I'm thinking of these regions here. And once this gets to 820, close enough to 828, I will stop it. Step. Okay, so this is the most recent image that at least I've downloaded. And yeah, basically all of this stuff from about here on, yeah, maybe even here on, is not visible. Okay, all of this we're just beginning to see in the Earth-facing sun. What we're beginning to see is just kind of the glow, what we call limb brightening. And the thing is that everything that's really close to the limb of the sun, so right, this is the east limb in stereo's view, that's the west limb. Everything that is near the limb always undergoes what we call limb brightening. And it's because of the projection effects. You have so much stuff that's kind of stacked up on one another, on top of one another, that things can look much, much brighter than they really are. So when they rotate to the center disk, they actually look pretty dim. But here they look really, really bright. So that's kind of what I'm trying to get a feel for right now, as to how much of this, the more that this region rotates away from the limb, I'm watching very closely to see how much this region is going to dim. If it doesn't dim all that much, if it stays reasonably close to this level of brightness, I would say yes, we could easily be in the 120s in about 5 days, maybe 6 days. If this dims a lot, we'll be hovering around 120, maybe just below it. But do I think it'll go up? Yeah, I think it'll go higher than 112. Because right now, again, we only have, on the Earth-facing disk, we have these regions, okay? These regions are really, there's just not much left of them. Now, this one looks like it's pretty bright, but, you know, again, that's limb brightening on stereo's view. If I flip to the Earth view, you'd see that this region is really not all that bright. But these regions, of course, will then, as this rotates into view, right, and it gets into here, we'll only have a few, maybe about 5 days before this one then begins to rotate off of Earth's west limb. When that happens, again, flux will drop. So we may only be up at the 120 range, or a little bit higher, assuming best case scenario. We may only be up at the 120 range for a few days before things quiet down. However, that being said, this is the set of regions, and I should go, you know what I should do? I have well, I'll do that in a sec. This is a set of regions that I know we've had a lot of, there was a lot of activity last time this set of regions rotated into view. So there may be a lot of stuff behind it. In fact, we are seeing the hint of stuff in the north. So some of these regions may have survived, and that triggered me. Let me go and look. Let me get a new tab. Let me go and look at the duplicate tab. Okay. what am I trying to say? I can't walk and chew gum at the same time today, guys. I want to look for, if I can find them, the synoptic charts that show all of the helioseismology stuff. Okay, so with Gong, so there's Earth side, far side. Yeah, we just have that. So we do have a strong far-sided structure here. That is that region that we're actually seeing rotating into, that's almost rotating into Earth view. I don't see a lot of other stuff on the far side from Gong, sadly. I will take a look at HDMO or HMI far-sided stuff. We have a movie here. Hold on. Let's do the movie. Here's the movie. I like this movie. So as you can see the date here, so this is March 10th, 11th. So let's hope it goes to as far as the 26th. We'll find out if it needs to be redone. So all the yellow stuff is going to be far-sighted, and what we're looking for are dark images, like dark spots like that. And it looks like, so this is what I was talking about, that stuff that, now this is now moving to the far side, but that stuff, when we saw it, some of it's still existing. You can see it here. And then I didn't get a chance to point out, but we had some stuff here that was also remaining. It looks like it's intensifying, as a matter of fact. So this stuff here, how do I explain this? Okay, so what we're looking at, anything that's gray means this is the HMI. This means the magnetic field imaging of the sun done directly. Okay, now remember, the sun is constantly rotating. So if we take the sun and we roll it out into a flat map, we get something like this. Okay, this is what we call a Carrington diagram. Okay, I know Carrington, but hey, it's still called a Carrington diagram or a synoptic chart. Okay, now it's latitude. So here's the equator. Here's 90 degrees north. Here's 90 degrees south. These are longitude lines, right? So you can see it goes 360 degrees all the way around like the sun. But here's the thing. For any one Carrington diagram, we don't have anymore. We do not have an imager, an actual physical eyes on the far side of the sun. So at any one time, we only have part of the sun in view. And that's what you're seeing in gray. And every single day, that view changes a little bit. Okay. So you're seeing what the Earth view is for a particular day. Here's the day, 13th, 14th, 15th, okay, of March. Okay. So it's changing. Now, the nice thing about a map like this is that even though the view of our sun is changing, the sunspots themselves stay pretty much pinned, right? They're almost always just staying there. They either, or the submarines are, if you've taken any of my mini courses, you know, the submarines will appear and emerge and then disappear. Okay. So the nice thing is that even as we lose our view, as the view changes, the sunspots will stay there. And so we'll be able to tell through helioseismology, which is the sounding of the sun, which is all the yellow stuff, that even though our view disappears, like right there, we knew a sunspot was there. And so we're watching. Is it going to emerge again? Yes. Look, see the dark? That's the helioseismology saying that sunspot had emerged again. Okay. Or it had done, the helioseismology got better. That's the thing about helioseismology. It's hard to sound through the sun. It's like a seismic activity all the way through the sun. And so we're trying to sound the far side of the sun and get an idea through this technique whether or not there are sunspots there. And so it takes a lot of pinging over and over again, a lot of observations, so to speak. I should be careful when I say pinging. It's not really active sounding. But it takes a lot of observations to kind of build up, your statistics to let you know, because we don't see a lot of dark stuff. But then as time goes on and you get closer to the center of the far side, yes, we are seeing it definitely. So are these regions still existing on the far side of the sun right now? Yeah, I think so. And so we do have stuff that, even though we can't see it in stereo's view right now, there are new regions that are on, or at least old regions that are still alive and well. You can see by the darkness here, we have some stuff in the north as well as the stuff in the south. This is the south as we go, as it goes to the sun's far side around the 12th. You can see that region still staying there. And let's see if it goes. No, there's the one I'm interested in right there. That's actually a new region. 25. Yeah, see, it's almost getting back to us. So that was a region here. It looked like it was beginning to form a little bit last time in Earth-facing disk. Yeah, you can see it here. See this? That's the region that's about to rotate back into Earth view. And so that's going to give us some good solar flux. You can see it's gotten really intense. And then some of these old regions over here as well. Okay. Hopefully that makes sense. These are not always the easiest things to to talk about, but I hope that made sense. Let me know if it didn't. But yeah, Bart. So there you go. If you happen to be on the feed, I didn't see if you were here today, but that's hopefully answers your question. And let me see if there's any other questions on Patreon really fast, because I will want to be sure to answer those. Sometimes people on Patreon are not able to join the feed live. Terrific. Did unusual solar winds, this is Spock's daughter, did unusual solar winds hit us early on the 24th because the extreme double RS? What does RS mean? RS spikes. We had, not sure what you mean by RS spikes. So radiation storm spikes? Not sure. But yes, we did. We did have the fast solar wind. That was from that original, I'll leave this here for a sec. That was from the original, the first of the 2 coronal holes. So we did have some fast solar wind that has been hitting us over the last, a few days ago. It's beginning to kind of calm down now. But it did bring us unsettled conditions. It wasn't a very strong burst of fast solar wind. And on top of that, it brought mostly northward field. There wasn't a lot of southward field because it's just the wrong configuration. Both of the coronal holes that we're dealing with, both the one that hit us, that gave us a fast wind stream a few days ago, and the one that's about to give us some fast wind, they're both positive polarity, and that's not the right polarity for this time of year, if that makes sense. So yeah, I don't know what RS meant though, so I can't really ask. I can't really answer that question. If you meant radiation storm, the radiation storms aren't really correlated with fast solar wind, only in rare cases, and definitely not in recent solar cycles. The fast wind hasn't been really fast enough to drive shocks. So radiation storms don't really get correlated with fast solar wind, if that makes sense. Okay, Susie Cat, always hopeful. Oh, cool. Yeah, keep your fingers crossed. I hope you guys in Scotland should definitely, in the upper UK, you should definitely be able to get some aurora, because you're at the high end of mid latitudes. It's the low end of mid latitudes that's a problem. Yeah, Spock's daughter. Oh, you are on SR. What is SR? Yeah, I don't know what you mean by that. Explain the acronym, and I'll do my best to help. Understood. 40. I know you're talking about. Are you talking about the amateur radio bands? And are you talking about the radio burst? Because I get that. Okay, no relevant questions, random conversations. Okay, thanks, Jerry. Appreciate it. Yeah, and I have now. Much appreciated, Jerry. I have now answered all the questions on Patreon, so I think I will go ahead and, yeah, I don't know. Solar radiation, I'm not sure. Oh, Schumann resonances. Oh my goodness. Okay, Schumann resonances, believe it or not, they don't have much to do with space weather. They have much more to do with terrestrial weather and lightning. Okay, so these are resonances that are really down in the low cavity in the neutral atmosphere, and they are very, very low frequency. We're talking hertz. So yeah, that. Pay more attention to lightning, pay more attention to terrestrial weather for Schumann resonances. I get people asking me that all the time. And I just kind of say, well, I need to get a degree in terrestrial meteorology to talk more intelligently about Schumann resonances, because it really doesn't have much to do with the cavity resonances that we see further out. That's all that stuff is much more terrestrial weather. So hopefully that answers that. Okay, I'll look at one or two more questions here. Notice the higher level of UV light, wondering if it's coming from spikes in solar activity. higher level of UV light? Well, yeah, the EUV and everything. I mean, the solar flux goes up. It all kind of goes up as the solar cycle, ramps up. Magnetic field strength goes up, light goes up, it all ramps up. I mean, you can see it even in the total solar irradiance. I couldn't think of the word. The total solar irradiance, the TSI. You can see the solar cycle, just like sunspot numbers going up and down. Sunspot numbers and solar activity, really does make a difference. Makes measurable differences in in how active our star is, both when it comes to space weather and how active it is when it comes to the solar flux coming from it. Okay. Oh goodness, Vince, you're asking a question that everybody asks. Is there connection with volcanic and earthquakes? I've answered this question so many times, and honestly, the answer is if there is an effect, we can't quantitate it or can't quantify it yet. Period. Because the geological forces are the primary driver. And as I've made the analogy so many times in the past, it's like having a bathtub of water, of soapy water, and there's a bunch of toys underneath that bathtub. Until you drain, you don't know, until you drain that water out of the bathtub, you don't know if the toys are there. The toys could very well be there, or they could very well not. But you won't know that until you drain that soapy water out of the bathtub and it reveals the toys. The soapy water is the primary geologic forcing of earthquakes. Okay, geophysicists aren't even close to being able to solve that problem. Is there a chance that electrodynamically there is coupling? Sure, why not? I mean, we have geomagnetically induced currents on the ground that can couple into power grids. So could space weather cause a piezoelectric effect? Possibly. I mean, there is a mechanism by which it could happen. Will the forces be comparable to geologic forcing? Not a chance. Right? Geologic forcing, again, that is the primary engine. And until scientists, at least mainstream scientists, are able to come up with some quantitative way of subtracting out that effect, we will never be able to quantify space weather effects. We can speculate all day long, but we can't quantify it. And that's the problem. That's the trigger for mainstream science to start working on something, is if there is no way to pull out quantifiable estimates that you can rely on, there's no funding to do that work. And it will remain the bailiwick of fringe scientists. And I still, God bless them, I've been chewed out a lot by mainstream science, especially a lot of geophysicists. They've chewed me out recently for daring to say that I appreciate the work that fringe scientists do on earthquakes and trying to correlate it with space weather. I will maintain that posture. And the reason why I maintain that posture is because fringe science pushes the envelope that mainstream scientists oftentimes forget is there. And they force mainstream science out of their comfort zones. Are they always right? No, of course not. I mean, that's why mainstream science is what it is. But mainstream science is always under threat of being calcified, right? We could easily calcify and not evolve. Fringe science allows that speculation to take fruit, to bear fruit. Mainstream science then can slowly but surely, assess some of these things that fringe science comes up with. But then again, fringe science needs mainstream science to rein it in and hold it back and make it accountable for its speculation. So in a sense, it's a nice little tug of war. And I think it's very, very important that we have both. And I will maintain that posture until I die. I am a mainstream scientist, period, right? I am not fringe, but I can appreciate fringe scientists for what they do and how they help expand the mind, right? And show us what is possible. Not necessarily what is real, but what might be possible. And that to me that's as valid as anything else, right? It's valid in terms of how it can help move the overall field of science forward. Okay, but mainstream will always be the ones who quantify, and God bless them for that. So hopefully that explains that. Okay. All right, guys, I think that's, with that kind of statement, I'm not sure I can do much more. Yeah, like mic drop, Ruby, truth boom. Yeah, true. Okay. All right, guys. Yeah, real talk. That's exactly right. So hopefully that helps you, at least helps clarify my stance on it. And I will be on Twitter, and I will be answering questions. All patrons, you guys know how to get to me. I will definitely answer more questions if you guys weren't able to get any of your questions answered here, or you didn't want to ask them here in this forum. Okay, so outside of that, guys, have a great one, and let's hope we get a good solar storm. Let's hope it hits early so we can get some decent aurora. Okay, take care. Bye.